Okay, we're going to try to do this curve sketching to find the critical points, inflection points, max mins, and all that good stuff. So my function is x to the fourth minus 8x squared plus 8. And I'm going to go ahead and take the first derivative, which would be 4x cubed minus 16x. And over here, I'm going to take the second derivative because I know I'm going to need it, which will be 12x squared minus 16. All right, now I want to be able to find my critical points. So critical points, I would set my first derivative equal to 0. I would go ahead and factor out a 4x to make this a little bit easier to solve. And so I set each factor, so I set 4x equal to 0 and x squared minus 4 equal to 0. And I solve each one of these for x, so I get x equals 0 and x equals plus and minus 2. Because when you move the 4 over, then you have to plus and minus when you square root it. So these are my critical points. I don't know if they're max or mins, and I can do this two ways. I can plug it into the second derivative and see at that point if it gives me a max or a min. Or I can look and see where my intervals are increasing and decreasing. So let's look at that. Look at my intervals, which is where I plug in my critical points. So -2, 0, and 2. And remember, you're plugging values in these intervals into the first derivative. So I picked -3. I picked -1, I picked 1, and I picked 3. And from picking each one of these, I saw this first value was negative when I plugged it in, so that's decreasing. This value was positive, increasing, negative, decreasing, positive, increasing. So if you plug in each one of those values into the first derivative, you'll see that you get a negative value, a positive value, a negative value, and a positive value. So I can certainly see the intervals, the intervals that it's decreasing until it hits that critical point. Then it's increasing, it hits the critical point. It's decreasing, hits the critical point, and then increasing. So it's pretty easy to see where my local min and maxes will be. So I'm going to have a local min at -2 and +2. And I will have a local max at 0. So what I want to do is I want to get the actual point, so I will actually plug in to my original function these critical points, and what this will do is it'll give me my y value. So if you go back to the original function and you plug these values in, f of -2, you should get -8, f of 0, you should get 8, f of 2, you should get -8. So at -2, -8, that's the actual point of my local min. At 0, 8, that's the actual point of my local max. And at 2, -8, that's my actual xy point, bless me, of my local min. All right, so now I'm pretty much done with that side. So I'm going to go back over here to this other side, and now I'm going to find my inflection points. Remember, you do that by setting the second derivative equal to 0. Again, I'm going to factor out a 4. So I end up with 3x squared minus 4. Of course, I'm just setting this factor equal to 0. 3x squared minus 4. So 4 over 3 equals x squared, and then I plus and minus the square root. And I go ahead and do this, so plus or minus the square root of 4 over the square root of 3, which is plus and minus 2 over square roots of 3, which is plus and minus 2 square roots of 3 over 3. Just happens to be the way that I wrote it out. All of those numbers mean the same. So now from here, I want to find, these are my inflection points, and I want to find the intervals of concavity. And so to do that, I take my inflection points and I do the same thing that I did with the critical points, but now I'm going to be plugging these into my second derivative. So in this interval, I pick a value, and I picked -2. This interval, I picked 0. And this interval, I picked a +2. And what that gave me was this interval was positive, which means concave up, and you can certainly see that happening over here. This interval was negative, so concave down, and then this interval was positive, concave up. And then finally, I would want to be able to plot these inflection points. So I go back to my original function and I plug in the -2 square roots of 3 over 3 and the +2 square roots of 3 over 3. And you should get, if you leave it as a fraction, -8 over 9 for both of them, actually. And so these are my inflection points, -2 square roots of 3 over 3, comma, -8 over 9, inflection point, and +2 square roots of 3 over 3, comma, -8 over 9. That's my inflection point. So also back up here, when you report the intervals that you're concave up, you would say from -infinity to that inflection point, and then this inflection point to infinity would be concave up, and then of course concave down would be the interval between the two inflection points. So when you get all of this information, what you want to do from here is you want to take and you want to plot every one of these points. So you can see I have 5 points here, and then you connect the dots. And so if I go look at the graph, I can certainly see there's all 5 of those points connecting the dots. In fact, I can get rid of the graph so you can just see the points there. And then based off of my information that I know it's increasing on this interval, I'm sorry, I said increasing, I think decreasing on this interval, increasing, decreasing, increasing, I can see what my picture looks like.